Next lesson is solving for the area of a circle. So, real quick review of what area even is. Let's say that you have a garden, and the garden is 1, 2, 3, 4. Let's go one more down. It's going to be a 5 by 4 garden. 5 feet. Well, yeah, it's a small one. 5 feet by 4 feet garden. And in the previous lesson, the circumference of a circle is the perimeter of a circle. And whenever you solve for the perimeter of a shape other than a circle, you add all the sides, right? The circumference of a circle, though, is when you multiply the diameter to pi. When you are solving for the area of any shape, not just of a circle, because this guy is clearly a rectangle, you don't add all the sides. Again, that's perimeter. You multiply. So 5 times 4 would be 20. So for example, 1, 2, 3, 4. There will be exactly 20 squares there. The area of anything that has 4 sides, such as a square or a rectangle, is length times width. And they usually give you a cursive L with that, with a dot, and W stands for width. And 5 times 4 is 20. Now, you got to be careful of how you label your answer. It's not 20 feet, it's 20 feet squared. Because when we solve for the area of any shape, you count how many perfect squares fit on the inside of that shape. So this garden's going to have 20 square feet, okay, of lining, that black lining that you usually put at the bottom of your garden. All right. I'm also thinking of bathroom tiles. So when you're standing inside of a shower, your shower, if you look down that your feet are on, those tiles, you have to do the math and do the length times the width to know how many tiles you need in order to cover the entire area inside that shower. If you think about our classroom, your feet are on tiles. You need to do the length times the width to know how much tiles it takes up for our classroom even. All right, you need it for gardens. You need area all the time. And this little 2 stands for squares, okay? That's why whenever we say, like, for example, 4 squared, that little 2 means that term, squared, because you actually use squares to discover how much squares you need for the inside of that shape. When you label your answer, let's just say with centimeters instead of squares, like this is squared, right? If I said if we're labeling this is going to be next week's lesson, but just a little terminology for you, centimeters cubed is when you use it with a little 3, because then you're going to actually use cubes for volume, and we're going to discover how many cubes fit inside a 3D solid, but that's next week. I just want to make sure you understand the difference between squares and cubes, because that labeling is so important. It's not 20 feet, okay? It's 20 feet squared, because you're actually discovering how many perfect squares take up the inside of that shape. When you're solving for the area of a circle, you still use squares. So draw a circle, and let's go ahead and say that we have a radius here. And the radius, let's say, is, it doesn't really matter if I just say the radius is 3 feet. But we need to discover how many perfect squares take up that circle. And if you notice, you're not always going to get perfect squares, okay? Because when you get something round, right, you got to form the curvature that takes up that square. So like right here, if I were to blow that guy up, he would actually look like this. So there's a formula we use to solve for the area of a square, all right? Because you're not actually finding perfect squares to know what fills in these missing little pieces. All right. And the area of the solving for the area of a circle, A stands for area, is pi times the radius squared, not diameter, the radius squared. That's what you're using today. So if we have the radius here that's 3, and we plug it into the formula, area equals pi times 3 squared, you got to solve the order of operations and get rid of the exponents first. So now you have pi times 9, because 3 squared is 9. And then, remember, I'm allowing you to use calculators on this. 9 times pi, you might need to round to the nearest hundredths place, which is that 7. That 4 leaves that 7. 28 and 27 hundredths feet squared. Okay, so we need actually 27 hundredths of a square, okay, to finish off those pieces. Let's keep going with this. Let's start with number 1. If they give you a circle and a radius of 7 inches, solve for the area. Well, I'm going to write down the area formula, pi times r squared. Area equals pi times 7 squared. 7 squared first, following PEMDAS. That's 7 times 7, that's 7 times 2. 7 times 7, which is 49. So let's go ahead and multiply pi to 49. And you get 153. Rounding to the nearest hundredths place, that 8 turns that 3 into a 4. So now you have 94 inches squared. Don't forget to label that answer. Look how I'm showing my work on a new line each time. Apply the formula, substitute it in, following the order of operations, rounding your answer to the nearest hundredths place, and labeling your answer properly. It's a lot to it. If you miss any of that, I think the overall concept is easy, and I'm allowing you to use a calculator. You need to make sure you're applying all of that, though, or else the whole thing's wrong. Number 2, let's go ahead and give you a diameter this time. If I give you a diameter of 24 millimeters, okay, well, the formula, remember, we need radius. So you got to ask yourself, pi times r squared, what's the radius if our diameter is 24? 12. So that would be 12 squared, right? Now applying the order of operations again, that would be 12 times 12, which we all should know is 144. So now you have the area times pi times 144. Notice Ms. Chiano's using multiple ways to show multiplication. This one I used the dot. This time I'm leaving it with parentheses. I'm going to show some rounding. 144 times pi, once you plug it in, you're going to round to the nearest hundredths place, which is that 8. You look to the right of it, it's a 9. That 9 turns that 8 into a 9. So we have 452 and 39 millimeters squared. Here's your answer. Number 3. I want to make sure we're okay on the rounding. You might do all the math perfectly, but it's the rounding that might throw you off. Number 3, let's go ahead and draw another circle, and I'm going to say the diameter is 14 inches. Remember, we only need radius in the formula, pi r squared. Area equals pi times what's half of the diameter, 14. That would be 7. Hey, it looks like something similar that we've had up here. Okay? So make sure you can make those connections. Okay, make those connections and don't give yourself extra work to do, because that's definitely going to happen. There's going to be times where you're not always going to be seeing a circle, but you're going to be seeing a semicircle. Half circles are called semicircles, okay, in geometry. I'm going to say our diameter is 28 meters. You still use pi r squared, but there's one more thing. Once you solve for the area, cut it in half. And that's the formula of finding the area of a semicircle. You still use what we're used to seeing if it were a full circle. Go ahead and get that, but then cut it in half, because we only want the area for what's inside this half a circle or semicircle. So let's go ahead and plug in what we have. Pi times half of the diameter, 28, is 14, so 14 squared. 14 squared is 196. We're not dividing by 2 yet. Pi times 196 divided by 2. Pi times 196 is 615 and 75 hundredths. Divide that guy by 2. 615, 75 hundredths divided by 2 is area equals 307 and 85 hundredths meters squared. You're still solving for squares. Okay, remember that's like doing this. Still, you're solving for how many perfect squares make up the inside or the area of that circle. Let's do another one like that. We'll end on number 5. I'm turning my paper over and we'll end on 5. So let's go ahead and do one that looks like this, a semicircle like this. And I'm going to go ahead and say that the radius is 3 feet. Well, that means the diameter would be 6, but we don't need that. We only need pi r squared anyway. That means pi times 3 squared. 3 squared is 9, following that order of operations. So pi times 9 is 28 and 27 hundredths once you round to the nearest hundredths place. I'll show you that real quick. Pi times 9. Okay, that 4, let's practice this rounding real quick. That 7 is in the hundredths place. That's what we're rounding to. You always look to the right of that digit. If it's 4 or lower, you leave it. A lot of people want to round that down to a 6, but that's not right. If you're rounding down, it would actually be 273 if you're rounding down. So don't do that. Leave it. If it was 5 or higher, so like if this was a 5, then you would round that digit up to an 8, but it's not. It's 4 or lower, so you leave it at 0.27 or 27 hundredths. It's a half a circle though, so divide that guy by 2, and then you'll have your answer, which is round to the nearest hundredths place again, and it would be 14. See, this is where you look to the right of it, and if it's 5 or higher, you round up, and it's a 7, so you round that 3 up to a 4. 14 and 14 hundredths feet squared. Okay, so that's solving for the area of a circle and a semicircle. Make sure you're careful of labeling your answers. Make sure you're careful of rounding and applying PEMDAS.